Question 13. So for this question, there are a few different methods to do so. So this will be the video 1 to show you the first type of methods to tackle this question. So it shows you the two tangents, AB and BC are the tangents to the circle, and D and E respectively, and angle ABC is the 86 degree. So you can write down. And then the key point is that the question wants to find out the angle DFE. This is the unknown. And you can see that the key here, because you got the two tangents here, so basically you think of the reason from for the tangents. And OD and OE are radii. Therefore, you can claim that OD boy and OE boy are 90 degrees due to the reason tangent perpendicular radius. And then what you can do is that you can find out the angle DOE by angle sum of polygon, because this is a quadrilateral with the total internal angle, the sum of the internal angle will be 360. And then lastly, if you get the DOE, then use angle etc. twice angle as circumference to get DFE. Okay, that's it. So let's start to write down the reasons for part A. So part A, remember to add a straight line on it. So angle B DO equals to 90, tangent perpendicular radius, and then angle boy EO also 90 because tangent perpendicular radius. Okay, next one. So due to the angle sum of polygon, then we can find out DOE. So angle DOE plus angle B dot O plus angle boy EO plus angle ABC equals to 4 minus 2 times the 180. Okay, angle sum of polygon. By substituting the value, okay, then you can write this line, and then angle DOE equals to 94. Lastly, use the angle as center twice angle as circumference. Therefore, angle DFE will be equals to 1/2 times the angle DOE. Write down the reason. Angle as center twice angle as circumference. Therefore, 1/2 times 94, then it is the 47 degree. Done. Mark down all the information back to your figure. Okay, part B. It shows you the arc ratio. Okay, highlight this one. So you can mark it down. This is 5 and this is 9. So basically, if you have this line, this arc ratio, basically you think of two reasons. Actually, it's the arc proportional to angle at center, or arc proportional to angle at circumference. For the video 1, we will looking at using the arc proportional to the angle at center. For the video 2, we'll focus on the angle at circumference, this reason. Okay, but no matter which reason you use, you get the same answer. Okay, so let's see. By using the arc proportional to the angle at center, then we may need to add one more line on OF. Then the DOF, this one will be 5x. And then EOF, this one will be 9x. By using the angles at a point, 5x, 9x, and 94 degree, then you can equals adding up, then they will be equals to 360. You can get the x. After you get the x, you see that OE, OF, and OD, these three are radius, okay, or radii. Then you can use the base angles isosceles triangle, okay? They are pairs. So whenever you use radii, this reason, next step must be a base angle isosceles triangle. Then you can, lastly, you can use the angle sum of triangle to find out the OEF. You can find out this one. So the last step will be the to find out CEF, means that you can use the tangent perpendicular radius to minus the OEF, this one. So let's mark it down. So how to write down the steps for the arc proportional to the angle at center? So let angle DOF equals to 5x while the angle EOF equals to 9x. Okay, the reason, arc proportional to angle at center. And then angle DOF plus angle EOF plus angle DOE equals to 360. Angles at a point. And then substituting the 9x in it. Then x will be 19. Okay, and then OE equals to OF, radii. Therefore, angle OEF equals to angle OFE is the base angles isosceles triangle. Angle EOF plus angle OEF plus angle OFE equals to 180. Angle sum of triangle. So the 9 times 19 degree plus 2 angle OEF equals to 180. Then angle OEF is actually equals to the angle OFE equals to 4.5 degree. And while angle OEC equals to 90 degree, tangent perpendicular radius. Therefore, angle, when we calculate angle CEF, then it is angle OEC minus the angle OEF. Then we get 90 minus 4.5. The final answer will be 85.5 degree. This is the first method.